With the rapid democratization of high-end video generation, local book clubs and neighborhood HOAs are on the verge of producing cinema-quality superhero movies about themselves. Seeing this level of raw capability creates an illusion about the internal mechanics of the technology. The public tends to view AI as an evolving, omnipotent black box, a single, massive digital brain capable of handling every type of reasoning simultaneously. However, this assumption hides the actual trajectory of the industry. Progress is now driven by architectural diversity rather than raw computational scale. Giant monolithic models have reached a point of diminishing returns. They are prohibitively expensive, consume massive amounts of power, and remain frustratingly unpredictable. This lack of predictability has led to new regulatory pressure, with proposed mandates requiring AI developers to report critical safety incidents within a 7-day window. To bypass these bottlenecks, developers are shifting away from massive generalist models to build ecosystems of highly specialized modules. This transition suggests that technological maturity comes from breaking intelligence apart, rather than forcing it together. This shift toward specialization is already visible in hardware. Take Floaty, a drone that abandons brute force propulsion for environment-aware micro-adjustments. Instead of using constant thrust, it uses 4 small flaps to passively ride wind currents, mimicking the soaring efficiency of a bird to save energy. Software is following a similar path, with spiking neural networks, an architecture designed to mirror the energy efficiency of biological brains. Unlike standard models that run continuously, these networks only spike to process information when critical new data arrives, reducing energy demands by up to 60%. These advancements suggest a new evolutionary rule for technology. Processing power should only activate precisely when and where it is needed. Apple's AI strategy follows this logic through an invisible routing layer. Rather than building one master AI, they are constructing a model router that delegates tasks between small local models and large web models based on the complexity of the request. Models like Micro push this further, splitting reasoning into 4 modules: language, logic, social, and world knowledge. When splitting a dinner bill, logic handles the math, while the social module simultaneously overrides the result, recognizing a friend lost their job. Dividing AI into these specific, observable modules allows developers to see exactly how a decision was reached, offering a level of transparency that massive monolithic models often lack. This modular approach offers a useful framework for understanding the future of human work, specifically through the O-ring model of labor. The O-ring model defines a job as a chain of links, where success relies on every individual piece. When AI automates routine links, the remaining human links, like communication and creative strategy, become even more critical to the company's output. In this context, high AI exposure doesn't lead to replacement. It acts as a value multiplier for a worker's unique human contributions. This multiplier effect, however, only applies to complex, multitask roles. If a job is built around only a few core functions and AI automates those specific links, the entire role faces a high risk of total elimination. We see this vulnerability in roles with very low task diversity, such as manual inventory sorting or warehouse packing. The same risk applies to other highly focused occupations, like long-haul trucking, where the job consists of a narrow set of repeatable tasks. Navigating this transition requires deliberate diversification of the tasks and contributions provided within your organization. As AI evolves into an invisible ecosystem of specialized thoughts, human success will depend on an equally adaptable, diversified mind.